Welcome to section 8.5, solving rational equations. I wanted to remind you guys that when we are solving linear equations or quadratic equations, whenever we had fractions, we multiplied each term by the LCD to get rid of any fractions. And this is going to be our same strategy for this section. The only thing that's different is previously we would just multiply it by a number, but now we're multiplying by a denominator. So we could lose domain restrictions. What this means is we could solve something and our solution might make the denominator 0. So when a solution makes the denominator 0, those are called extraneous solutions, and we have to make sure we throw those away. We do not want to include those in our solution set. Alright, so let's hop to it. Let's solve this equation. So I wanted to just point out some differences. We have an equal sign. That's telling us we need a different strategy. And our strategy when we have an equal sign and polynomials in the denominator is to multiply each term by the LCD. So to find the LCD, we have to factor each denominator completely. So I'm going to try to line up the factors. Alright, and then the other two are actually already factored. There's nothing else we could do to them. They're prime. Okay, so it looks like we need a 2x plus 1 and we need an x minus 3. So our LCD is going to be that 2x plus 1 and that x minus 3. It also means, since it's in our denominator, 2x plus 1 is not allowed to be 0, and x minus 3 is not allowed to be 0. So in our solution set, let's make sure we don't submit 3, and let's solve this. So subtract 1, divide by 2. Let's make sure we do not include negative 1/2. That would make the denominator 0. Those would be extraneous solutions. Okay, so our LCD then, we already touched on it. 2x plus 1 and x minus 3 is going to be our LCD. Notice all our denominators can multiply into 2x plus 1 and x minus 3. That's why it's a common denominator. So let's rewrite our equation and let's practice multiplying each term by the LCD. And as I'm rewriting it, I'm also going to factor as we go so I can see what term we're missing or how we can cancel the LCD. Parentheses are important. Okay, so we're going to multiply both sides by the LCD. We are not making common fractions or equivalent fractions. We're multiplying each term by 2x plus 1 times x minus 3. That's going to clear all of our denominators. And then we're going to be working with just a normal equation. Okay, so let's see what happens. Let's rewrite what we have. So we're left with x squared minus 23 plus 2 times 2x plus 1 equals negative 1 times x minus 3. Okay, so let's clean that up a little bit more. So get rid of your parentheses and combine like terms. Okay, so this is what we're going to work on solving, and that's step 5. So I notice we have a quadratic, and it's nice to remind ourselves of our strategies right now. sometimes we'll end up with a linear equation. That's when we isolate the variable. If we have a quadratic, we make one side 0, factor, and use the 0 factor property, or quadratic formula. So what's our strategy here? We're going to make one side 0. So let's add x to both sides. To get rid of this negative x, we can add x to both sides. To get rid of the 3, we can subtract 3. So adding x, subtracting 3. All right, and we can factor this one. So we'll factor and then use our 0 factor property. So that means x plus 8 equals 0 and x minus 3 equals 0. So solving for x, we're going to get negative 8 and positive 3. All right, and step 6 is to go back and to check, because if we were to plug in 3, we would make our denominator 0. Let's go all the way back up. And that's what we established in step 2. If we were to plug in 3, this denominator would be 0. 2 over 0 is a no. We're not allowed to do that. So when we submit our answer, we're going to have to throw away that 3. And so our solution is just x equals negative 8. Okay, so let's try another one together. Here we're asked to solve. So again, these are our instructions. Our instructions are to solve, and we see an equal sign. So our final answer, let's remind ourselves, should be p equals some number. All right, so that's when we have a equation we're solving, we end up with a number. Okay, so our denominator, step 1. Let's factor everything. And this one's a little bit different because we have numbers, but it's going to be the same process. All right, so we definitely can't have p be 3. In our LCD, we need a factor of 2 and 3, so 2 times 3 is 6. And how many copies of p minus 3 do we need? We need the largest power, so we need p minus 3 squared. And that's our LCD, so we're going to come in and we're going to take each of our terms and we're going to multiply it by the LCD. I'll factor as we go. Okay, so here we go. We'll multiply the first one by 6p minus 3 squared. Our second term, let's multiply it by 6 times p minus 3 squared. Remember, parentheses are important. And our third term, we'll multiply it by 6 times p minus 3 squared. All right, so let's see what cancels. So in our first term, p minus 3 squared will go away. Second term, 1 copy will go away, so 2 minus 1 is 1. We'll be left with 1. All right, remember that middle term, it's all multiplying. So p minus 2 times p minus 3. And same here. Okay, so what is that? Let's see. So in our first term, it's going to be 6 times 3 plus 2 times p minus 2 p minus 3 is equal to 3p times p minus 3. Okay, let's clean this up a little bit. I'll FOIL this out first. Order of operations. We can go left to right with multiplication for that middle term. All right, and when everything is completely simplified, we see that we're going to have a quadratic. So our strategy is to make one side 0. All right, so let's keep going. This is a long problem. Okay, so I'm also going to combine like terms. And now let's start making one side 0. So let's subtract 2p squared. So we'll get p squared. Let's add 10p to both sides. So we're left with 7p. And we'll subtract 30. There you go. All right, so make one side 0. Are there two numbers that multiply to negative 30 and add up to 7? Multiply to negative 30 and add up to positive 7. Good, 3 and 10. Excuse me, negative 3 and 10. So our solutions are negative 10 and 3. But what's wrong with 3? It makes the denominator 0. So we'll have to throw it out. And we would always see that once we check our work. All right. So final thing is you guys are going to solve 1, 2, 3 of these on your own. And then you guys can come back and check your solutions. All right, let's see how we did. So solving everything, or factoring everything completely. We see that x plus 2x minus 2, oops, sorry about that, is our LCD. So we're going to multiply the whole equation by x minus 2, x plus 2. So in our first term, what we had was the x minus 2 cancels, and we're left with x plus 2. Second term, the x plus 2 cancels, and we're left with x minus 2. And then on the other side, x plus 2 and the x minus 2 cancel, and we're left with the 4. All right, so let's see what happens. We're going to get 2x. 2 minus 2 is 0, so 2x equals 4. And we get x equals 2. All right, and then what do we notice when we try to plug that back into the denominator? It makes one of the denominators 0, so we have to throw it away. And we're left with nothing, so we can just write no solution. All right, and we'd have to show all our work. We can't just write no solution and get full credit. All right. And this next one,